The topic is hashing technique. In this video, I'll be discussing about why we need hashing, what is the use of hashing, and what is the ideal hash function, the base idea about hashing. Then we'll see what are the drawbacks of ideal hash function. Then we will see modulus hash function, then its drawback, and what are the possible solutions. So let us start why we need hashing. Now let us understand why we need hashing. See, hashing is useful for searching. So if you have the list of keys and you want to search some key from them, then you can use hashing. So for searching, we already have some known search procedures. Yes, those are linear search and binary search, which we have already learned. And we already analyzed them, and we know that the time taken for linear search is order of n, and the time taken for binary search is log n. So log n is faster than n. So we know faster searching method, that is binary search. So we want still faster than this one. So what is the time that is more smaller than this one? That is 1 constant, or any value that is less than log n. So we want a search method that is less than log n. So yes, for that, idea of hashing technique is introduced. So hashing will try to search the keys less than log n time. So almost constant time. So let us compare these. First we will, So let us compare these, linear search and binary search, and then hashing. So for explanation, I have taken set of keys here, and these keys are stored in an array as it is in the same order they are kept. Now if the keys are as it is kept in an array which are not sorted, they are not in any order, then upon this we can perform linear search. So for performing linear search, we don't want keys in a particular order. The next one is, same keys I have kept them in the sorted order. If they are in sorted order, then we can perform binary search. So the requirement for binary search is the keys must be sorted. So this is the extra work that you have to do. If you want to apply binary search, then make sure keys are in sorted order. So for keeping them in sorted order, you have to put some extra efforts definitely. So binary search time, that is log n, can be achieved if you are putting efforts in keeping the list in sorted order. Now the third idea, that is hashing. So if we have the keys, then how they should be arranged so that we can find them in constant time. So here already I have taken an array to show you how these keys should be stored. Let us store these keys here. 8 should be stored at index 8. Then 3 should be stored at index 3. 6 at index 6. Likewise 10, 15, 18, and 4. So key is stored in the same index. Rest of the indices are empty, they are blank, they don't have any keys. So you can put there 0 or -1 to show that keys are not there. So key itself is made as the index and it is stored there. So now if I want to search for any key, let us say I want to search for 10, go to index 10, yes, 10 is there. How much time it takes to find out 10? Just constant time. I want to find out 18 is there or not. Go to index 18. So I don't have to check rest of the keys. Directly go to index 18. It's there. Yes, there. So key is found. Now suppose I want to find out a key 7. See, 7 is not there. So okay, go to index 7. Yes, it's not there. So directly go to that particular index and find out key is there or not there. It's taking just constant time. Yes, this is fastest method of searching. Yes, hashing is fastest searching method. Now drawback. The drawback of hashing is, see, I have only 7 keys available here. But what is the size of an array? Size of the array is 19. I must take 19. I have taken 20 till 0 to 19 I have taken. So I must have space 19 for this one. Because the largest number is 18, then I must have an array up to index 18. Right? So if suppose the next number, if I want to insert in this list of keys 100, then I should have an index 100 also in an array. So though I have only 8 elements, then I may be having 100 spaces. So a lot of space is required and lot of space is wasted. So this is the drawback. So we have to do something to reduce this huge consumption of space. So for that, let us start studying about hashing. So for studying about hashing, we'll represent this hashing in some mathematical model. So that mathematical model we will look at now. Yeah, let us look at mathematical model for hashing. These are the set of keys. Those set of keys, let us assume them as key space. And this is hash table, the array where we will be storing the elements or the keys. This is hash table. Keys should be mapped on hash table. So it is just like domain and range. So the elements from domain are mapped on the elements in range. So this is like a relationship. So mapping domain upon a range is a relation or a function. So let me show you what are the types of mappings available in the relations. So there are 4 relational mappings. Let us look at them. Yeah, here are 4 relational mappings. Out of these 4 mappings, one-to-one and many-to-one, these are called as functions. These are called as functions. So yes, function is a type of relation. So here we will use a function for mapping. First of all, let us map them based on the idea that I have given you. So let us map these. 8 should go at index 8. Okay, it is here. Then 3 should go on index 3. Then 6 should go on index 6. 10 should go on index 10. 15 on index 15. Then 9 on index 9. 4 on index 4. See, this is one-to-one mapping. Yes, every key is mapped on one index in a hash table. It is one-to-one mapping, this mapping. So it is called as function. So what is the function used here? See, the function h of x, if I give, means x is 8. Then what is the answer here? 8. If I give 10, h of 10, answer is what? 10. So h of x is equals to x. This is the function used here for mapping keys on a hash table. So we say that we are not storing the elements directly. We are using hash function. That hash function is giving us the index and we are storing a key at that index given by hash function. Yes, this is the idea. So next time when you want to search for any key, whom you should ask for index? Again hash function. Suppose I want to search for 9. H of 9, answer is what? 9. Go to index 9. See, hash function has given us the index or location where that key is present. I want to search for 12. H of 12, answer is 12. H of 12 is 12, right? Go to 12. It's not there. Key is not there. So using hash function, we will map the keys on a hash table so that for searching also use same hash function for finding an element. So when we say function, function supports 2 types of mapping, that is one-to-one or many-to-one. So our function that we are using here is one-to-one function. So this function h of x is equals to x, we call it as ideal hashing, because the time taken for searching or storing or deleting an element is constant. Just use the hash function and go and store the value there, and use the hash function and retrieve the value, so the time is constant. The time is equal to the time spent by hash function. So this is ideal hashing. Now let us talk about the drawback of ideal hashing. The drawback of ideal hashing is the space required is very huge. Lot of space is required. Even though I have only 7 elements here, then the array space I have is 0 to 16. And if I have one larger key here, like suppose I have 100, then I should have an index with 100 also. Then only it's possible to achieve ideal hashing. This is the drawback. So who is responsible for this drawback? Hash function. Who is giving the index? Hash function is giving the index. So hash function is responsible, ideal hash function. If I want to reduce the space, I want to achieve same thing hashing in limited space, then do what? Modify hash function. Modify this one. Now let us see how we can modify hash function. How much space I want to provide? I want to provide only 10 spaces, that is 0 to 9. So if I am providing only 0 to 9 spaces, then hash function should be changed. Otherwise, for 15 it will give the index 15, 15 is not there. Now let us modify hash function. So I am modifying hash function. H of x equal to x mod 10. So I will remove this space. I will take only 0 to 9 indices. Now the hash table size is 0 to 9. I am ready to provide only the size of 10 only because I have 7 keys. So I think 10 is sufficient. So I have taken space 10. So what should be the hash function? Hash function is modified that x mod 10. So this hash function will never give you value greater than 9. So you get the values from 0 to 9 only because it is mod 10. Now let us map these values once again using that hash function. So let us start. 8 mod 10. See, 8 mod 10. Mod means remainder, right? Remainder. When 8 is divided by 10, remainder is what? 8 only. Because 8 divided by 10. So it doesn't get divided 0 times. So 0 only. So remainder is what? 10. So it is 8 only. So this 8 is mapped on index 8. Then 3 mod 10. 3 only. So it's mapped there only. 6 mod 10. 6 only. Then the 10 mod 10. 10 mod 10. If this is 10, 10 once 10 and remainder is 0. So we get the index 0. So 10 should be stored here. So this modulus function has given the index 0. So I have stored there. Now 15 mod 10. So if it is 15 mod 10, 10 once 10 and then subtract this, remainder is 5. So remainder we got 5. So 15 should be stored at index 5. So that's how all the keys are stored or mapped using this hash function. Now let us see the problem with this modulus hash function, the drawback of modulus hash function. If I have a key value 25, where it should be mapped? 25 mod 10. So 10 will divide 25. So 10 to 20. Remainder is 5. So this 25 is also mapped on index 5. This location only. See, 15 is already present there. Then 25. There is no space for 25. So two keys are mapped at same index because we have modified hash function and this modulus hash function. When two keys are mapped at same location, we call it as collision. So there is a collision of keys. And if you observe one thing, two keys mapped at same place, many to one. So this function is not one to one. So this function is many to one. So more than one keys may be mapping at the same place. Yes. 15 will be mapped there. 5 will also map there. 25 also, 35, 45. Any number ending with a 5, digit 5 will be mapped there only. So if you have multiple keys, all will be mapped there only. So this is collision. So this is the drawback of modulus function. When you modify hash function from ideal to any other function, then there is a problem of collision. Because ideal hash function is 1 to 1 and any other hash function if you write, if it is not 1 to 1, then definitely it is many to 1. So many to 1 means more than one keys will come on same index and that is collision. Now how to resolve this collision? So I'll show you what are the solutions for resolving this collision. So next we will see what should be done for avoiding collision. Now let us see what are the methods for resolving collision. So if a function is many to one and if there is a collision, two or more keys are mapped at same place, then how to solve that problem? So for solving the problem, there are two major methods: open hashing, closed hashing. First I'll tell you this difference. So first I will say what is closed hashing. See, the size of the hash table is a 10 and this is the space given. So we will utilize only that much space only. We will not increase the space. That is closed hashing. Then what is open hashing? We will consume extra space. Beyond this hash table, we will take more space. So that's why that is open hashing. And in that open hashing, method is chaining. Method is chaining. We will look at these methods. So one of the method is chaining. Then in closed hashing, three methods are there. So these are under open addressing. So I'll explain what does it mean by open addressing. If two or more keys are mapped at same place, if there is collision, like suppose 25, I got the same index, but this place is already occupied. Hash function has given this place, but it is occupied. So we'll store it at any other free space. So we'll not strictly store at a place where hash function has given the address. We may store it at any other address. So that's how this is open addressing. But the question is, where will you store? There are three options: linear probing, quadratic probing, and double hashing. So we'll look at all these methods in next videos. So that's all about introduction to hashing and ideal hash function.